Hi, everyone. This is a handout that I created for my students on the basic moves in the Kalam cosmological argument. The Kalam cosmological argument is one that we get from Islam. It comes from Al-Ghazali, but it's been recently popularized by the Christian philosopher William Lane Craig. And it goes like this. Premise number 1, whatever begins to exist has a cause. Premise 2, the universe began to exist. Conclusion, therefore, the universe has a cause. So let's break down each one of these premises one by one and see if the conclusion follows from the premises. And what I've done here in this handout is to start with a premise, consider a possible objection to the premise, consider possible responses to the objection, and so on and so forth. I think you'll see how it goes along here pretty obviously. Let's look at premise number 1. Whatever begins to exist has a cause. Now, Dr. Craig says, quote, does anyone in his right mind really believe that, say, a raging tiger could suddenly come into existence uncaused out of nothing in this room right now? The same applies to the universe. If prior to the existence of the universe, there was absolutely nothing, no God, no space, no time, how could the universe possibly have come to exist? Craig thinks that this is an a priori intuition or is self-evident. Now, the first objection I'm going to consider here goes like this, that many people don't find it to be self-evident like Craig does. So Wes Morriston says that, quote, anyone who claims to have an a priori intuition at premise 1 must be prepared to explain why other equally informed and intelligent persons who have attended closely to it, nevertheless, fail to see that it is true. If it is so obvious, how can they fail to see it, end quote. So the example here is subatomic physicists. So people who study physics, quantum physics, think that this principle, well, many of them think that this principle doesn't hold, at least on the quantum level. But there are some possible responses to this objection. The first one is that there are many higher level mathematical principles which are self-evident, which I take on faith, but may not be to lower level students who are not able to grasp it like me. So it is with this causal principle. Just because I don't understand it, just because we don't understand the principle to be self-evident doesn't mean that it isn't. Possible response number 2, a weaker but still effective move is to change this from an a priori claim to an empirical or inductive claim. So we have inductive evidence that whatever begins to exist has a cause. Now, this isn't a response that I've ever heard Craig use to defend this principle, but it seems like one that might work. It just weakens the argument as a whole because it turns this a priori intuition into a posteriori or empirical claim. And so it is accordingly less strong than it would be if it were an a priori claim. Now, maybe because the a priori claim doesn't hold up to scrutiny, it's a way of saving the argument to make it this weaker empirical claim. But whatever the case, I think this is a possible response to the objection. Objection number 2, again, we're objecting right now, we're considering objections to premise number 1, whatever begins to exist has a cause. So in objection number 2, subatomic physics furnishes an exception. Some subatomic events are said to be uncaused. Well, there's a possible response to this. The Copenhagen interpretation that quantum level events are truly indeterminate is debatable. Truly meaning ontologically determinate is debatable. Both Einstein and David Bohm argued that this indeterminacy is only epistemic. The laws of nature are determinate. God, quote, doesn't play dice with the universe, end quote. Once we have an understanding of deeper reality, we will be able to predict events on the subatomic level. So the idea here is that the right understanding of quantum physics is debatable. Some physicists think that it's ontological, that there are no causes at that level. Things are just popping into existence randomly. Others think it's more epistemic, that we just don't understand it yet, but someday we might be able to understand it. And I've talked to a few physicists about this, and there are different minds about it. I think what I gather is the general consensus is that the Copenhagen interpretation should be interpreted ontologically, Nevertheless, it seems like there might be some room there to interpret it epistemically. I'm no physicist, I can't comment on that. I would recommend you talking to your physicist friends, especially ones who have higher degrees in this and may even have a background in philosophy, to really explore this possibility. But a possible response number 2 is that even under the traditional interpretation, quantum events do not come into being out of nothing, but out of fluctuations of energy in the subatomic vacuum. A vacuum is not nothing but a sea of fluctuating energy. So there's a difference between what's going on in quantum mechanics, quantum physics, and what we're talking about at the beginning of this universe. So premise number 2, the universe began to exist. What reasons do we have to think that that's so? Well, the first argument to consider is that if the series of events in the universe leading to the present were infinite, then an actual infinite would exist. But this is impossible, and Craig likes to use the example of Hilbert's Hotel. The idea of Hilbert's Hotel is, imagine this fictional hotel that has an infinite number of rooms. And let's say that it is full, so there's no vacancy. But imagine that a new guest walks into the lobby asking for a room, and the manager says, sure, I'll make some room for you, and goes to the first room and asks the person who's in room number 1 to move to room number 2. And then the person who's in room number 2 to move to room number 3, and the one in 3 to 4, and 4 to 5, and so on and so forth, to infinity. So on infinite set theory, this would be possible, thus making room in that first room for that new guest. But in the actual world, that kind of thing doesn't make any sense, right? It might work in mathematics, but the claim is that it doesn't work in the actual world. A hotel that's full is a hotel that's full, has no vacancy. The objection to this argument is here that an actual infinite can, in fact, exist. Consider Zeno's paradox. If you're not familiar with Zeno's paradox, imagine you're in a room right now and you've got to move to the door to get out of the room. But in order to get to the door, you've got to traverse half the distance first, right? But in order to get to that half distance mark, you've got to traverse half of that distance, and so on and so forth until you've cut up that line, that distance, into an infinite number of distances apart, and you are paralyzed. You can't get to the door. So there's a response to this, and that is that Zeno's paradox is a potential infinite, not an actual infinite. If you assume that the distance is already composed out of an infinite number of parts, you beg the question. So the distance between here and the door isn't already divided. It's divisible. You can divide it, but you need not to. It doesn't exist divided right now. Secondary argument number 2, part A. The temporal series of physical events is a collection formed by successive addition, meaning adding one thing after another. Part B, a collection formed by successive addition cannot be an actual infinite. You cannot create an infinite set by adding one after another, because you can always add one more. You'll never complete the set. Therefore, the temporal series of physical events cannot be actual infinite, because we are in a series of physical events that is adding one event after another. And so it can't be an infinite one. Objection to this, Zeno's paradox. The infinite is traversed. But the possible response is the same in that case, because Zeno's paradox has some problems. Possible response number 2, Zeno's paradox is, Zeno's task is disanalogous to this infinite series. Zeno's distance is potential and unequal, while Craig's is actual and equal. Objection number 2, a successively created past can be infinite if it never began. But the response to this would be, if one cannot traverse the past by beginning in the present and moving backwards, then one cannot traverse it by moving in the opposite direction. A rebuttal? One can traverse the past moving in a forward direction because one does not start doing so. Well, response to that? Any enumeration can be reversed, so it doesn't prove anything. Secondary argument number 3, the Big Bang theory. The Big Bang argument that the universe began to exist is this idea, this theory in cosmology, that we live in an expanding universe that started with an initial explosion of this singularity type thing. that occurred a long, long time ago. And so this makes it sound like, it looks like on the surface, that the universe began to exist at this point a long, long time ago, this singularity. But there are some objections to this. There are other cosmological theories out there. For example, the oscillating universe, this theory that the universe actually expands, but then collapses in on itself, and then explodes again and collapses in on itself again. This is over long periods of time and goes on forever. But the response to this is that the Big Bang model is the current reigning paradigm. And so we're just going with science on this. We're just saying that, look, most scientists think that the Big Bang model is actually the right way to look at the universe, and we don't have any evidence or much evidence for the oscillating universe theory yet. Objection number two, the singularity may be a timeless state. So as opposed to actually starting to exist, the singularity may have been around for a long time in a timeless state. The possible response to this is that nothing that is now material could have an initial timeless state, understanding space, time, and how all that's connected. Possible response number two is a transition from a timeless to a temporal state can only be caused by a person. And so the idea is that if we have a timeless cause, then you would have the effect existing eternally also from all eternity with the cause. But that's not possible, except for when you have a mind or a will involved in it. So this personal cause is invoked here. So if Craig is right, the first two premises establish that there is a cause of the universe. We're still far away from that cause being the God of monotheism or Christianity or Judaism or whatever, or Islam. So what do we have then? So Craig then tries to make the case to move from a simple cause to the God of monotheism. And this is the cause of the universe must be 1, uncaused, 2, immaterial, and 3, personal. And just briefly, his case goes like this. It must be uncaused because you can't have an infinite regress of causes. He's already shown that, he thinks, in the course of this argument. B, it can't be immaterial because we're talking about space-time here. And so it has to be immaterial. It can't be material because everything that's material is what's in question. How did it come to be? So it must be uncaused, immaterial, and then finally personal. And this is the tough one. So an eternal, non-personal entity would exist with its effect eternally, but the universe is not eternal. We know the universe is finite. At least that's the idea here from the argument. And so again, if the cause existed eternally in a timeless state, the effect would exist eternally along with it. But the effect, the universe, doesn't exist eternally, is the idea. And so he cites there are two kinds of explanations in the world. If you look at my footnote here, you can see there are gnomic or law explanations and personal explanations. And so because law explanations only pertain to the physical world, we're talking about something outside of the physical world, we can rule those out. And really the only other type of cause that we know or understand are personal causes of agency, me raising my arm or me choosing to do things. And so that leaves us with this personal cause as the cause of the universe. And so there you have it. That's the argument. Is it any good? Well, overall, I think it's a good argument. There are 3 weaknesses that I'd like to point out here. I've already pointed out some of them, but the first weakness lies in the plausibility of its first premise being a priori. Again, I suggested that it possibly could be weakened to an a posteriori or empirical principle, but that would weaken the argument. So that's, I don't know if that would be acceptable. Number 2, the weakness also lies in the reliance on a certain interpretation of quantum physics. And so whether or not that's true, I think we have to leave to the physicist, but that could change, right? Science changes and our opinions or thoughts about the universe change along with it. So if we're tying the argument to science or physics, then we to be consistent, we have to go wherever physics goes, and that might change in the future. Finally, there's a weakness in the reliance on the current Big Bang paradigm. So as I've mentioned, that paradigm has been challenged in recent decades. And so even though right now we're on sturdy footing because that's the reigning paradigm, the argument might collapse if the Big Bang theory is no longer acceptable. So there you have it. I hope you found that helpful.